Hello everyone. Very good morning to all. I am Saitya Roy, Developer Edition at KryptoNaukri. On behalf of KryptoNaukri, I welcome you all to our first day of Solidity Development Workshop. Now let's talk about KryptoNaukri. KryptoNaukri is providing the best blockchain developers to the startup by providing an innovative learning ecosystem where developers can learn blockchain development, solve problems during development through community, gain experience as an aspiring blockchain developer by working on DAOs open source projects, get unique identity as a blockchain developer, and get jobs in verified Web3 startups across the globe. We have more than 400 plus blockchain developers across the platform. Also, we have onboarded 30 plus Web3 startups who want to hire from us. We are organizing a hackathon, that is Web3 Hack, in the month of July. Beforehand, we are conducting 10 plus events and many more workshops in our platform so that students can learn blockchain development, students can know what is Web3. After that, we will conduct a hackathon in our platform. So today we have our special guest, Ms. Nikita Kotme. She is blockchain developer at KiwiTech. So today she will be talking about basic of Solidity and many more stuffs related to Web3. So now I hand over this virtual stage to you, ma'am. You can start.
Thank you so much for the kind introduction, Saitya. And yes, as you rightly said, that we are going to explore much of a Solidity and how to create our own cryptocurrency. What is the basis of that coding? Okay, so all of that we are going to explore in today's workshop, and I hope you all will enjoy that session. Okay. Yes. Okay. So, yes, we have. I have the information that earlier the workshop was held and the basic blockchain topics were covered, isn't it? The basics of blockchain, why it has come into picture, and how it is just getting evolved day by day. Yeah, with all the cryptocurrencies getting into the market, and why people are just following that. Yeah, why it is so booming in the market. What is this blockchain technology? I'll just give you an overview, and then we can just dive into the Solidity, how we can just proceed further. Okay, so blockchain is nothing but wonderful technology with the help of which you are going to change the world of how that practical experience is changing of the banking sector or the financial sector or the educational sector, or any of which we can say the industrial sector. Now suppose if you want to just have a transaction between a point A and point B, or between two friends. So this current system, how this current system is working right now is we have to go to the banks, then there are many more third parties, like there is a friction getting created in the system, and we have to pay for every other system where we just want to transfer some amount of x amount of money to a y person. Yeah, so with this, we are going to just eradicate or just remove all of these third parties or the friction which is created in the system, and we are going to have a peer to peer transaction from X to Y. Yeah, that's a very super cool idea with this blockchain technology. And not only with the cryptocurrencies, we are able to apply this blockchain technology in various applications. Okay, in the financial fields, in the healthcare centers, whatever we just see as in a commodity or in a shop. If we want to buy some commodity, okay, and if we want to know this commodity is been freshly prepared by that farmer, or at what temperature it is, or what the conditions they have met, with that barcode scanner we can just get to know. A simple application I'm just giving you, not only cryptocurrencies right now in the world. What people are just thinking about blockchain is, yes, we have to generate or we have to create a cryptocurrency that is a token that is only blockchain. No, it is not restricted to that application. It is actually not restricted. We have to just think and go beyond our ideas, that how this application or how advantageous and what all benefits we can just get from this technology and apply into our real world life problems, and we can just solve those. Okay, so today we are going to just deep dive into Solidity. Okay, now what is Solidity? like all applications have some base language to create those, like in any other gaming parts. Right now in our current field, wherever we just create any application like the Myantra, or what we can say about make my trip and all of these are example just built on the JavaScript language. Okay, now this JavaScript is a base code language for just getting any application made, okay, or just to create an application and just regularize into the market. But whenever a blockchain technology is concerned, all these language are concerned, but the base language is the Solidity language. With the help of this Solidity language, we are going to write smart contracts. Now, what are smart contracts? These are nothing but the logic for which the application is written, okay, or for what we are coding. Okay, so these are just a fancy word. Just don't get confused between smart contracts and or whatever we write for our application in our real life basis with the JavaScript or Java or something like that, any other language. We just say it as a code. In here, blockchain terms, we just call it as smart contracts. With the smart contracts, we are writing whatever that application should work for, or what is the requirement, or what is the project for. Okay, so we are going to see what is the basic terminologies, or what these keywords are there in our Solidity, so you can just refer it and then we can just start coding on it. Okay, so our today's agenda will be, we'll just see the Solidity basic terminologies, what are different from the other language and what are restricted in Solidity. Then we'll just try to create our own cryptocurrency, okay, based on a remix platform. Okay, so I'll just share my screen and then we can just start with this. Okay, I hope the screen is visible to you all. Superb. Okay, so let's start. What is Solidity? As I told you, it is a language of the blockchain technology where you can just write the smart contracts. Now, Solidity is the version pragma is used as follows. Okay, whenever you just start writing any JavaScript code, okay, you just try to import one line as import and then the libraries and all. Okay, the very first thing, the very first line in a Solidity code or a smart contract, it should include the pragma Solidity and the version name. Right here it is 0.5.2. Okay, it's just an example. Now there are some versions which are getting updated in the market, like if there is a code like in the Java, also in the JavaScript, wherever there is some updations coming up, the compiler version changes. Okay, so these are nothing but the compiler version. We are just making sure that this compiler version should match our Solidity code, and it should run accordingly. It should compile and deploy. Okay, let's come to that part later. But the very first thing which you need to mention it in a Solidity code is pragma Solidity and the version name. Here it might be 0.8.10 or 0.8.1, whatever the versions you are referring for. These versions are having some updated keywords or updated inbuilt functions inside it. So what is your requirement of the project, you have to just see accordingly and then use that compiler version. Okay, Solidity supports import statements to help modularize your code. Yeah, like how we use import in any other languages, in JavaScript or Java, Python, and all. We can use the import statements in Solidity as well. So we have to just simply write import and then the file name, whatever what is the file name we have to import. Again, there are two three import statements which support Solidity. Is import star as symbol name from file name. Okay, now if there are some smart contracts, okay, now there are projects where you have to write two three smart contracts. Okay, now in this two three smart contracts, we are making an dependency on each of the other. Okay, so if we want to just import some of the file name from other file, okay, or some other smart contract, you have to just import it in a way like import star as symbol name from file name, from which file name it is, okay. Import file name as symbol name, okay. This is an alternative statement. So these are the first two three import files or the instructions which we can give it in a Solidity language, okay, where import whatever the file name you have it, and then the symbol name. Why we are focusing it on the symbol name? Because in every other cryptocurrency or whatever token you create, there is a symbol name to it, or there is what we can say, if there is a class name, that is the token name we can say. If it is, my name is Nikita and I'm going to create a token named as Nikita, so I'll be just creating a Nikita token. So what is the symbol for it? A short symbol, like how we have Bitcoin BTC, I'll have NKT token. Okay, so that is a symbol name for my cryptocurrency or the token which I'm creating. So if I want any of the token to be utilized in some other contract, or I want to just refer it, I will be writing in the form of import statements, like import file name as symbol name, and then the import symbol one as alias symbol two from file name. If you want to import two three symbols, okay, from different contracts, okay, there are some code in our JavaScript also, we make interdependency, and we can just create a connection between two three codes. Yeah, in the same way we can make a connection between the smart contracts with these types of instructions, how we want to import it. Okay, let's come to the types. Now every language, okay, whether it would be application based and now it is a blockchain technology based, it will have types, okay, the data types. So what we can use in our Solidity types is, first is the boolean. We all know that boolean, it might be true or false only, okay. So that is what we use it in a similar way for other languages also, that is similar in Solidity, not to worry. Operators also are little bit same, apart from this JavaScript and what about the languages which we are creating in the market, is logical negotiation, then the logical conjunction, what is the and operator, we can say logical, or we can say equality sign and inequality sign, or not equal to sign, we can use the same in our Solidity. Then there are integers. Now integers are a little more they have a more importance in our Solidity. Now there are unsigned integer and signed integers. Whenever we are going to have an application, okay, based on the output which is an integer. Now as we see that blockchain is always a transaction, even if we just share a information, not a cryptocurrency, if we share a information, that is covered under the name as transaction only, okay. So these are nothing but, if we are making a amount transaction, okay, not the information one, when we are just exchanging some cryptocurrencies, that will be an unsigned or signed, okay. So there are types as uint 8, uint 16, uint 32, 64, 128, 256. Most probably we are making the use of uint 256 in our blockchain coding, okay. That is more preferable in our Solidity, okay. So most of it you have to just remember that uint 256 we can just use it, and that is more preferable in our Solidity language. Signed also comes in picture, but it is very rare in our case, okay. So there are comparison operator, bit operators, shift operators, arithmetic operators, same as we use it in other languages, okay. So what is same in other languages and Solidity, I'll just point it out, and what is different, then you can just remember those points, okay. Then there comes an address part. This address is unique in Solidity. Now, in any other languages apart from Solidity, you will not find any data type named as address. Okay, because blockchain technology is based on the addresses which we get. Okay, now we in the market see that blockchain technology is public, we can see every other entry which is done in the transactions, and to from which address to other address. Now what I'm talking about these addresses, if we create our account, okay, that we create a wallet, we get a public address, okay, we get a public key from where you are going to transfer x amount of money to y person or vice versa. Okay, with the help of that address only, you will be able to do all of these transactions. That is a unique address. Every other person gets that unique address. If you don't have that address, then no one can recognize you. Okay, so these address are alphanumeric characters, and these address can be just given to some other person to have the transactions done. So this address data type is different in Solidity, which you will not find in any other language, because this application only is different. Yeah, so address holds a 20 byte size. Okay, size on Ethereum address. Okay, size of an Ethereum address, basic bytes are 20 bytes in an address. If you must have seen in any blockchain account, if you create it, okay, or a Bitcoin, if you want to just have a test nets, okay, whenever we are going to start with the Solidity of creating a cryptocurrency, you'll get to know that what is this address in detail, how we can just give it to some other person if we want their token, or how we can just store that private key and the public key. Okay, but just remember, address is the important part. Whenever you have to do any transaction, public address is a must. Okay, these addresses can be payable also, and they can be ownable. That means whenever we are saying that address payable, same as address, but with the additional members transfer and send. When we add a payable thing to it, okay, payable keyword, which is an inbuilt keyword of Solidity, where you can just say that if it is there in the code, you can just transfer it from the owner's account. Okay, when we are going to create the code, or we are going to create the token, when we deploy it, from which address it is deployed, that becomes my owner's address. Okay, then only I can just transfer some amount of money and just receive some amount of money. Okay, the operators remains the same: less than, equal to, greater than, equal to, not equal to, and whatever it is, just similar to other languages. And there comes one more thing as a balance of, as we see this technology is in the application of most of it, the transactions or the banking sector. We have a balance of, like, if we want to know balance of my account, so I will be having one address. So with that address, I have to type dot balance, and then it will be returning me in the form of UN256. That is a number, that is an integer. So here we are just you will get to know that UN256 is used, and the address which are given in the angle brackets, we have to mention our public address there, dot balance, then you can just get the balance of your own address. Transfer and send. Transfer is address dot transfer. That means if I want to add transfer some amount of cryptocurrency from my address to your address, you have to just mention your address also. It is in the to form. Okay, so address dot transfer, what amount you want to transfer, just write it, and then you can just move further. Okay, or you can just do that transaction ahead. Send given amount of v to addresses throws and failure. Okay, so if that transaction is successful, you will get nothing. Basically you will just see it in a scan, what we can say is etherscan.io. If it is ether transfer, then it is shown in the etherscan.io. And if it is a failure, then you will get a notification in the console bar that this transaction has been failed due to so and so reason, whatever the gas amount is less, or the amount entered is wrong, or something like that. Okay, that should be what we can say, the console it should show. Okay, whenever it is a failure. Address dot send is UN256 amount and returns bool. Okay, so in this case, dot transfer and dot send have two different things. It returns bool, or that means true or false value, if that particular amount of money or the cryptocurrency is sent from X to Y. Okay, so send given amount of V to address, return false on failure. Okay, the same thing which we see. Now, this minor difference you'll get to know when we'll just have a look at the cryptocurrency token which we are going to create. Call is nothing but the same thing how we can give a function call to it. This is an address call. Okay, it will just give an call to an address. It will return true or false if that particular transaction is successed. Delegated calls are again uh, a category of it where you can just issue a low level dedicated call whenever any transactions. So there are some sort of transactions which are important, really important, and which we can just ignore it. Okay, so these are the delegated calls which we can give to that particular transaction, and they'll return false on failure. Call code, we'll just see it in that coding section as well. Arrays is again the same concept where we use it in our other languages. We have a dynamic size array, we can have fixed size array here as well. We know that many variables, if we want to store, we use an array, because if var x is equal to 0, that means it is going to store only 0 value, or var x is equal to 5, so 5 will be stored in x. If we want to store multiple keywords or multiple values inside a variable x, then we use arrays concept. Yeah, we just denote it with a square bracket, and then we can just save different data types also, not only the number but with the characters also. Okay, so the same concept applies to Solidity in terms of arrays. Fixed byte arrays is the same. Now enum is a very important part. Like you can just have, okay, let's come to a layman's term. Now suppose you are playing a game. Okay, in any game you have waiting stage, then the playing stage, and then the game over stage. Okay, suppose we are just playing NFS. Okay, now NFS, we are Need for Speed. Okay, most of the people must have played this game. We are playing it with our friends, and now my friends, there are 5 friends. I have logged into the game, and I'm waiting for the rest of the 4 of my friends to just logged in. Okay, my second friend has also logged in, then we both are in the waiting stage. Third friend has logged in, we three are in the waiting stage. Fourth, and then fifth. After the fifth member has logged in, then my game is going to convert from a waiting stage to a playing stage. Yes, so that is what my, we can just say that waiting stage is my 0th stage, playing stage is my 1 stage, and game over stage is my second stage. So 0, 1, 2. So we were in the 0th stage first, then when we just logged in, we came into a playing stage. Okay, and then after everyone has played the game, ranking was done from 1 to 5, we all went to the game over stage, that is the second stage. Okay, now in the same way, smart contracts also have these stages. These stages are termed as an enum. Okay, enum work just like in other every other language. Like we just give game states, we here give as smart contract states. Like if, for suppose, we are just launching a cryptocurrency or a token, and when we have created that token, I'll have a pre-launch stage, and then the launch stage, and then the post-launch stage. Yes. Now the pre-launch stage, if I am in the pre-launch stage, I can't be within the rest of the 2 stages as well. Yeah. At a time, I'll be in only one stage. Like very simple example in our day-to-day life, we, the human beings, also have stages. We have childhood stage, we have teenage stage, we have adult, and then the old age. Yeah, so we can be only in one stage at a time, we cannot be in the 2 stages at the same time. While I'll be in the childhood stage also and in the adulthood stage at the same time, no, that is a mental part. But physically we cannot be in 2 stages, correct? So in the same way, a smart contract has to be in a particular stage at a particular defined timing. Okay, how we are going to code it? Like if we give simple instructions to a robot that you have to go left, now the robot will go left only, will not go right at the same time. Yes, so we have to mention our smart contract stages in the enum thing. Okay, and in these enums we are going to have stages, okay, to whatever the code should follow. After what condition it should be in that stage, after which condition it should be in the next stage. Okay, so these are the important thing which we need to just take care of, and we have, it's a good practice of having all of these is what we can say keywords or having these all functions in our code to have a proper coding style of any other cryptocurrency or any other application based on the blockchain technology. Now this action choices is of yours, whatever action you want to give it. Okay, it should be flexible. Now struct is also a different thing in Solidity. Struct is nothing but a structure we are going to define to our code. Now suppose I have a school application. Okay, so there are some things which are given into the students category. There are some things which are supposed or just targeted to a teacher thing. Okay, now if a school application is there, there are student category, there are teachers category, there are senior teachers category. Okay, so I'll just create a structure for these three categories differently, and whatever code in the rest of the code, if I want to call out any of the category, I'll be just calling out that particular structure. Suppose school is my structure A, teacher is my structure B, and senior teachers is my structure C. So these structure A, B, C are different. And then structure A, if I am concerned with the schools only, with the students only, if I want to call out a function which is related to students, then I'll just call the structure thing. This keeps our code a organized way and just optimize our lines of coding. Okay, whenever we want to call a particular structure, we can just give it a call with function structure name. Like we can just define it in this way: structure name curly braces open, whatever data types you want to store. Like in the student section, what we can be storing is the name of the student, the age of the student, which class he is in, and what is birth date. Okay, so these are the four data types which we want to just store it in a structure student. Now structure teacher will be having some different thing. What is her role in that school, or what is her, what we can say, what are the work allocated to him or her, or what is his age, then what is his salary, kind of thing. Okay, so all of these will be in the structure teacher, then in the structure senior teacher. So if we categorize our code into this, and which the Solidity prefers to go in the structure format, then we can just type in the structure name to which we want to just refer, and it just helps us in a smooth way and just contact with them, and just have a smooth transaction between all of these technologies. Okay, so this is a structure thing which is new. Enum is new, structure is new, mapping is new. Now mapping is different here. Okay, you cannot, you may have not seen any other uh, languages, a mapping keyword where this concept is there. Like you have to mask a value. Mapping is nothing but masking a value. Okay, like if I have a value, suppose I've declared a value. Okay, let's see the syntax for it, and then you can just refer it to how you can just apply to the application. Declared as mapping. Okay, mapping with the underscore key type, then the arrow is given, then the value type is given. Okay, now suppose here you assume that mapping A, and A is there. Okay, in the key type A is there, and we are giving an arrow and writing a value type as 5. Okay, if initially the A value is 5, now I want to change the A value to 10. Okay, now how to change that? I will simply write mapping key type, I'll write A, and the arrow value type, I'll write 10 to it. Earlier the value of A was 5, now I am changing it to 10 through mapping. Okay, so and it will be changed. Now how it is this powerful that mapping is helping us to mask a particular key type. Okay, mask a particular value. If we don't want that value, we can just make it or update it with the help of mapping keyword. Okay, with this mapping we are able to do this operation without any hustle, or we don't have to just declare it many times and then the value will be changed to a particular value which we wanted. So that doesn't have, okay, that is not the case. So with this, it is helping us to easily change the value of a key type without any operation on it, okay, without any big operations, or we can say big hustle on it. Okay, so mappings can be seen as hash tables which are virtually initialized such that every possible key exists in a mapped to value. Okay, so this also you'll get more clear when you'll start coding. Control structures remains the same for all of the other languages which we see. If else works the same way, while do, for, break, continue, return, and ternary operator. Okay, there are functions. Now functions also remains the same function. What is the parameter? Now here it is in detail, like how we can just define any arguments also in the functions of the Solidity, where the syntax differs a little bit. Okay, that is function parameter type. Okay, now we'll come to parameters type also. There are input parameters, output parameters also. Then there comes a curly braces where it is internal or external, public or private. Okay, let's come to this again and just see this function syntax. Okay, just read it in your mind once and then we are going to just go in deep what all these are, what is the meaning of this and how we are going to use it. Okay, now functions parameters, there are access modifiers. Access modifiers is public, private, internal and external. Public, that means if we want a particular contract to be seen to everyone, okay, or a particular function we want to see in to be everyone, or the transfer function. Now suppose we have created a cryptocurrency and a token. Okay, you want to transfer it to someone else, that transfer function should be visible, obviously. Yeah, then only that creation is of use. Okay, so public, if we make that function public, it is visible to every other person. Okay, if we make it private, so there are some functions in our organizations also, or in our what we can say applications of the project, that some functions need to be private. Like I want to keep this calling of function to these 2 3 members only, then I'll call it or make it private function. Okay, then there are some internal functions where they can be accessed only within the contract. So if we define any function as internal, throughout the contract it should be called internally only, we cannot call it as externally. Okay, or we cannot give a call from one contract to other contract because it is already declared as an internal function. Okay, internal access modifier. There comes the last type is as external. External means they can be called external only, they cannot be called internally. Now if you will see carefully, you might be getting confused between public and external. Is public is you can call it internally or externally throughout the code, throughout the contract and everywhere. Externally is you can call the access modifier wherever you have just defined it, or the function or the keyword only externally. Okay, you cannot call it internally. So these are the minor differences between these four access modifiers, like how you are going to make a particular function public, private, internal, external. Okay, now there comes a parameter, the second type where we are just going to refer it. Now firstly we have just discussed about these access modifiers, and now let's come to the parameter type. Parameter types are nothing but the input parameters and the output parameters. Okay, input parameters are declared just like variables. Okay, whatever the input functions you want to give or input parameter to give. Yeah, like event A and event B. If you want to have a transaction between A and B, or A account and B account, you will give input parameters as function A and B. Output parameters are nothing but we are going to return something. Yeah, so if event A and event B, I want to have an operation, some for example addition of those, then you will be writing it as underscore sum is equal to a plus b returns event sum. So you want to have a output with the addition of the two numbers which are passed the input parameters for it. Okay, so these are the simple definitions for the arguments or the parameters which we are passing in the function. These are input parameters, output parameters. Okay, constructor is also a similar kind of thing, like we deal it in with the other languages also. But the constructor here, okay, you have to see whether a contract name, okay, so functions that has same name as contract, the functions which are having, just understand it carefully, functions which are having same name as the contract name, they can be called as constructor. Okay, now we separately call it as constructor also. But if you just see it in a code that my function name and my contract name is similar, then you will not refer that contract name to as contract, you will call it as a constructor. That means it is the constructor of my code. For example, here contract C curly braces open, we have given address owner event status. Again, a function name I have called C event status and all of these things. Now here in Solidity, okay, there is a rule: function and contract name cannot be same. If it is same, then that contract name is not a contract, it is a constructor. Just simple two things you need to understand it, like how we are just making it a little overview of Solidity right now. So contract and function name cannot be same, it is not the rule, it can't be same. Okay, if it is same, then that contract is a constructor. That means here my this contract is a constructor, not a contract name. We are just referring it to as a contract, you can call it as constructor also. Okay, so that is the thing here. Then we can give function calls similar way, that's not the external function calls, also the same way. What different is there in our Solidity apart from the uh, other languages? Function modifiers. Now function modifiers, okay, we'll just do it this in our code itself. Pure functions, payable functions, yeah. Okay, super cool. Inheritance is also the same way how we use it in all other languages. Here also is the same how we can inherit the properties, but there are some differences in the interface. So interfaces are similar to abstract contracts, but they have restrictions. Like what are the restrictions? What these are the key features you have to just remember. They cannot have functions implemented, cannot inherit other contracts or interfaces, cannot define constructor. It is about the interface, okay? Don't get confused into the inheritances part. Cannot define variables, cannot define structs, and cannot define enum. So these are the differences between Solidity and the other languages. Okay, so these we can just see it. Events are also nothing but the functions. Okay, now events declaration and function declaration is the same, but whenever we just call it, okay, definition is the same. When we are going to call it, event is going to trigger some line. Okay, now with the events, when they are triggered in a console window, we'll get to see that this particular function is being run or is being performed. Okay, or this particular transaction is being carried out. So some coders are having a good habit of using the events every time, but they might use and not use also. But it is a good practice that if you want to check whether this function is perfectly called, then you have to try to use events also in your code or smart contracts. Then you will get a line that this event has been triggered, that means your transaction has been successful. Okay, so declaration is both the same, the use is different. Okay, events just records everything, functions do not record everything, they just executes. Event also record a particular task. Okay, they just see this transaction is being carried out between A and B or whatever it is just destined for. Okay, so this is the part of events. Libraries are the same thing how we use it in the other languages. Error handling is also one important thing. There are three things: there's assert, there is require, and there is a revert. It also works in the similar fashion like how the other languages have. Assert will throw if the condition is not met, to be used for internal errors. Now suppose I have a library function of addition a plus b, okay, or a minus b, but my a value is 2, or suppose, yeah, let's take a as 2 and b as 5. Now I want to do a minus b, that is 2 minus 5, okay. So 2 minus 5 will give me an minus 3 answer, correct? As mathematically, if we see a minus b is 2 minus 5, I'll get minus 3. Okay, if we haven't used unsigned integers like this or signed integers, then this minus 3 has to be internally converted to plus 3 and given as an output. Okay, so at this type of error handling, there might be some errors which are executed within the contract. Okay, so this type of error handling, if we want to have our code possess, okay, or our code should be capable of handling all of these errors internally, then we'll use assert for that. Okay, require is something we want to just have a check if this particular is having if this particular person is having that access or not. Okay, like suppose if I'm transferring x amount to b amount, a to b. Okay, suppose I am transferring 100 rupees. Okay, for example, you take 100 tokens. Okay, 100 tokens to the b token. So we'll have a check that my balance, okay, the sender's balance is greater than 100 tokens. Okay, the value entered is not less than 0. So these are what required checks which we can just mention it, because we know that computer is dumb. We have to just give every other instructions in a simple or a precise way where he can understand it and execute it accordingly. Okay, so whatever the possibilities are there, if we see that this error can also might happen, okay, that too comes with the practice and habit and how we can just code it. So that just logic comes up, and then we can use all of these error handling things smoothly, and our code runs it, okay, actually. So required and revert is nothing but if that particular condition is not met, my code should revert that transaction, or should revert that call, okay, the function call whatever we have given to it. Global variables transactions, not that important right now. Okay, come on, let's dive into the cryptocurrency, okay, and then we'll have a look of how we are going to see it. Okay, do we have any questions up till now? Yes. Okay, everyone can see this remix. Is the screen visible, Sahitya?
Yes, it is visible.
Okay, okay. So now this is a remix, which is a platform where we can create or create a smart contract. Okay, we can compile and we can deploy as well. Now, as I said, that we are going to create a cryptocurrency. Okay, within this time limit, we cannot just write one by one line and then code it. So I have just pasted a code which I have created on a token. I'll just explain it to you line by line so you can just understand it. How this particular code you can also write it. Now there are some multiple ways. Okay, so with this remix, there are some libraries, open zeppelin kind of thing, where you can just create a cryptocurrency on the basis of that open zeppelin library between only 20, 12 to 14 lines of code. Okay, but I haven't used that open zeppelin for now, because you need to understand if there are no libraries kind of thing. Earlier we used to write these smart contracts in this fashion only. Okay, so whatever the important parts are, I'll be explaining it to you. So you can just go and refer to this as well and try to code your own cryptocurrency. Then you can just build any application. If the basics are not clear, even though you will use updated libraries and all, that would be a just superficial knowledge for you. If you don't have any basics of how it has come from or how it is derived from, then you will have a confidence that you can just build anything on top of it. Okay, so this is a basic contract for creating a cryptocurrency. Okay, this I have uh, just let me show you what is the basics. Now in this contract, whenever you open this remix, you will be having this contract as scripts, depths, and all of these kind of things, artifacts. Not to worry about those, you just need to go to contracts, double click on it or right click on it, create a new file. Okay, with a new file, what you have to do, you have to write a file name and dot sol. Dot sol is nothing but a extension for a solidity. Okay, so dot sol you have to mention it, and then you have to just go to your particular file, and we have the code here. As I said in the very first thing when we started the basics of solidity, we have to write the compiler versions to it. So I have used a very old version for now to demonstrate it to you, 0.4.20. Okay, this is the very first line. You have to write it. Apart from this, if you don't write this, you are not going to compile this. Okay, it is not going to compile itself. You need to have a compiler version for it. Okay, the first, so the two checks you need to see is the license you have to see, and there is a pragma solidity line, we'll write it. Now these versions you can just select it within this compiler things. Okay, now on what basis or what application you are going to write it or what is the code for, you can just check it, and then you can just have a look over which compiler suits you. Okay, so many of the people right now are working on this 0.8.10. Okay, that is a little stabilized one. So every other 2 3 months or 6 months, solidity what we can say, the people just update their versions with some more specifications or some more features added to it, and they just launch it, and then people can use it for making any applications on it. Okay, so here I have used a 0.4.2. Whenever we just right now I have just copy pasted the code, and you have to match this compiler version with this. Okay, if I'll just select any other compiler version, and if I say I want to compile this, okay, it will automatically take 0.4.2. Okay, but if it does not takes it, you will get an error that compiler version does not matches. Okay, you have written compiler different compiler version and you are executing with different thing. So the very first check you need to have is compiler versions need to be saved. Okay, so this and this needs to be seen. Let's come to the main code of how we are going to create a cryptocurrency. Okay, now this cryptocurrency which I have created is a class token. Okay, will not go into this library safe math that is very much similar to the other languages, like function multiplication I have used, division, subtraction, and addition. Okay, let me just take one and then we can just move ahead. So within this input parameters, what I have passed is in UN256A, UN256B. So two parameters I have passed it input. Then that function should be internal. That means this library I'm going to use internally in this .sol file. Okay, in this smart contract, that should be pure. Pure means we are going to make it a particular transaction, a pure transaction kind of thing. Yeah, pure, it should return what? Bull, or whatever it is, it should return a UN256. So whenever it is bull, you will get true or false. Whenever it is UN256, whatever the operation is carry forwarded within this input parameters and what is the function written here, we are going to get that value. So that is return C. Same thing is done with the division, subtraction, and addition. Now let's come to the main part of the contract. Now, how this contract is to be written. Whenever we are going to code it for a token, it will have a contract. Okay. Each cryptocurrency token one contract. Okay, so whenever you are creating two tokens, you will have two smart contracts. Three tokens, three smart contracts. Okay, one token, one smart contract. It goes hand in hand. So contract class. Okay, I have given a name for the contract as class. Using safe math for UN 256, I am just referring that I should use the library which I have defined earlier. Okay, then there is a name for the token. Okay, so that is class I have written. You can just rename it, and whatever the token you want the name for it, you can just mention it like Nikita or whatever you want it. Okay, so this is the name where we defined it. It should be string public constant name. Public, that means my token name should be visible to every other person. Okay, if I would have made it private, then it would be just visible for myself or whatever I have given the access for. Okay, so that is important. That string public constant, I want to make this name constantly. Okay, I want to use this name in throughout the code. I just don't want to change this name anywhere. Okay, so constant name. Then there is a symbol to it. So every token has a symbol to it, like Bitcoin BTC class. I may vary it. So it is just given as CLS. Then there are 18 decimal. Now why 18 decimal it is concentrated is one ether. Okay, if you might have seen that one ether in our Indian rupees is around 13 lakhs or some kind of value it is. Okay, if I don't want to just transact one ether, okay, I want to transact only 500 ethers. Okay, 500 means in our terms. Okay, like one ethers, one of 500 times. Okay, so that is in a decimal points. Okay, where you have to just mention it whenever we are writing it in the decimals. When we mention it in the 18 decimals, you are able to transact the smallest unit of ether. Okay, that means you can just transfer 0.00000001 ether, which will be equivalent to 500 rupees for now. Okay, so that is the thing where we have to just what we can say, use the code base for it, like standard value for it. So some people might use 8 or 10 also decimals, but that is not the correct way of coding. So just try to standard your token and use decimal as 18. Okay, now the next line is total supply. How many tokens I want to create? That is total supply. I have 2.5 billion. Okay, I want to create 2.5 billion of class tokens. So you'll be defining it in the event public total supply. Okay, and this thing, now why I haven't written 2.5 and I have to write it in this fashion only? Because Solidity does not support floating point numbers. Okay, floating numbers. So if you want to make it and if you want to give that particular value in our code, you have to write it in the terms of decimals, like 10 into the power of 18. Okay, like how we have used the decimal 18. So 25000 into 10 raised to the power of 18, then it will be total amount of the total supply is 2.5 billion. Okay, then the address public owner. Okay, that is we are defining it as owner. So here all of these things we have a variable declaration. Okay, we have just defined some variables for what word I will be using for what. Okay, like owner, that means I will be deploying this contract, and whatever address I am deploying it, that is my owner's address. Okay, so I will be transferring some tokens to some other tokens or some other people, whatever it is. Now when we are creating a token, okay, it is a mandatory factor that you have to give a face value to it. Face value is nothing but what I have written it here as a price token. Now I am creating a class token CLS, one token. Okay, now one ether should be equivalent to 20,000 CLS. Okay, so I am just declaring it, like if someone give me one ether, I am ought to give him 20,000 class tokens. Okay, CLS tokens I will be giving. So that is what the ratio I am deciding If someone gives me 2 ether, I will be giving him 40,000 class tokens, and so on. Okay, so that is the value you need to decide for your token on the basis of the platform which you are creating it on. Okay, like we are creating on Ethereum platform, we'll just equalize it with our ether. Okay, like how much ether if you give it and how much token I will give it to you. Okay, so that is the price token. You and number of tokens, these are the variables which I have defined it. You will just get to know in the later part of the code. Let's see with the pre-start date, ICO start date. Okay, so like this, which I have told you that enums. Okay, there are some stages. Now ICO is nothing but initial coin offering. Okay, initial coin offering, that means we are creating a token. Okay, that is just a fancy word. We are giving it to a creation of the token. Like I am creating an ICO. What you are doing? You are just creating a token. Okay, you are creating a cryptocurrency. Now that I am just bifurcating with the pre ICO stage, ICO stage, and the post ICO stage, whatever it will be. Now in the pre ICO stage, just get a gist for it. In the pre ICO stage, what I am trying to do it here, apart from these 2.5 billion, I'm going to reserve some amount of token which will be launched in the pre ICO stage. And within that pre ICO stage, if someone buys that token, I'll give some bonus token also with that token. Okay, why I'm doing this? Because I want to marketize my token. I want to have a mouth publicity of my token. If we are creating the token and we are not just making or regularizing it in the market, that is of no use. Okay, so if you want to just have what we can say market value to it, or if we want to just propose it to the market, we need to come up with these marketing styles as well. Yeah, if you are making it in the pre ICO stage. Now I'll just make here. Now if you see, there are stages. This is non started, then there is a pre ICO, then there is a ICO, and there is an ended stage. So there are total 4 stages in my code, that is in my smart contract. The very first thing is not started. That means I haven't created it, I will be deploying it, but I have not started the generation or transferring of the tokens. That will be my not started. Pre ICO, that means whatever I discussed with you, like within that stage I will be giving some bonus tokens on the basis of that. So that is the pre ICO thing. ICO, that means that token has some stability in the market, and I have just started my ICO stage where people can buy. No bonus can be given. Only they can buy and just have a transaction. Ended is if I want to just stop generating and I want uh, just to stop the smart contract working, I'll end this, and whatever the tokens are regularized in the market, they'll be just getting exchanged, or whatever what we can just say, how it should be transferred to one and another, and make profit out of it, or make money out of it. Okay, like people, how people are just doing it in all the markets. So these are the stages which I have defined. It's not compulsory that every people creating a token will have these stages. Okay, it's up to you. It's up to, as you are the owner, you are the creator of your own your own token. You decide what stages to have, what not to have. Okay, it's just an example I'm giving you. I'm just covering all of the points. These points you might also cover, or you can just neglect some points, and then on basis of that you can create your own token as well. Okay, so that is not a hard and fast rule that you have to cover all of these points in token creation, and then only you can create a token, or you can just marketize your token. No, these are some of the checkpoints which a token creator should have it in mind, and then it will be benefits for him or her to have regularized in this market. Okay, so these are the stages. Modifiers, let's come to the main part where you are going to deploy it. Now see, function class coin, I am making a function class coin as a public. Okay, now owner, I am just making it sure that owner is equal to the message dot sender. Okay, whenever I'm going to deploy my contract, my address will be there. That address needs to be referred to as owner address. Okay, means that is the owner of that class token. What should be the balance of that owner? 1.25 billion. So out of 2.5 billion, which I have the total supply for CLS token, I am making 1.25 billion as the owner's balance. Okay. So I am giving to 1.25 into the owner's account. That is where the owner can transfer from his or her own account and then just do it in the market. Okay, now this should be in the stages not started stage. Okay, at the enum stage I am just telling. In the function public payable, function public payable, that means you need to have a check. Now here the error handling purpose things comes up require that stage should not be equal to the stage just dot ended. It should not be in the end stage, obviously. It should not have a stopped thing, yeah, that not stopped, and message dot sender is not equal to owner. If these two conditions are there, you cannot be the owner, or you cannot use this function, or you cannot call this function. Stop means I have stopped the creation of ICO. Not stopped, it is written, so it is in the generation of ICO. Yeah, so this check we have to just have it. If stage is double equals to stages dot pre ICO and now is less than or equal to pre end date. So what we are doing it here, if stage is equals to stage pre ICO, after the not started stage, we are in the pre ICO stage. After the pre ICO, we'll go into the ICO end. Okay, so these are the four stages. So one by one, we are just moving on to once from one stage to the other, another stage. So in this pre ICO stage, what should be there? Number of tokens message dot value, it should be multiplied. Now this is the bonus calculation. Okay, what is the logic we are having in this part, where it is in the pre ICO stage, where I told you that 1.25 billion is in the owner's account. The rest of the billion amount is going to be in somewhat like the pre-ICO stage, okay, and then the ICO stage. Now, in this pre-ICO stage, we are going to give bonuses to the people who are buying our tokens. On what logic we are going to give the bonus to the people is written here. It's bonus cal pre. Okay, now bonus cal pre is nothing but we are making sure that 1 month, okay, my 1 month will be my pre ICO stage. That means my token will be in a pre ICO stage for 30 days. Within that 30 days, I'm going to distribute those bonuses. Okay. So, the very first day, okay, when we have started the pre ICO stage, the very first day, if someone is buying a token out from me, I'll give them 30% bonus. Okay, till 15th day. Okay, what I'm doing, bonus calculation is equal to 0, bonus is equal to 30. Okay, till the 15th day, okay, of my pre ICO stage, I will be giving them 30% bonus. Okay, so first day, second day, third day, up till 15th day, if I have given some tokens to someone else, they are buying within the bonus limit, or what we can say the pre ICO stage, then I'll be giving them 30% bonus. After the 15th day, what I'm doing, I'm decreasing the bonus by 2%. That means on the 16th day, they'll be getting a bonus of 28%. On the 17th day, they'll be getting a bonus of 26%. Then 24, 22, 20, like this at the 0th one, okay, till the 30th one, they'll be getting the bonus as 2% only. Okay, then after that, my ICO stage will start, no bonuses will be given. So that is the bonus cal pre logic I have written. You might differ it also. You want to keep it for 15 days, you'll write it for 15 only. Okay, you win bonus if you want to give it as 15%, 15, 90%, 90, 50%, 50. So it depends upon the developer how you want to calculate it, or what the bonus should be. If you don't want to keep bonus, you're free to do that. Yeah, so this is a bonus cal pre, bonus calico factor, like how we are giving it to the people. Okay, this is the code basically which we wanted to have it for 15, the 25, then 40. That is a next stage. Okay, for from the pre-ICO to the ICO. Now how this, okay, now see, in the start pre-ICO, what amount I have? Max cap pre. Max cap pre means 350 million only. I'll be keeping it in the pre-ICO stage. Okay. 900 million only I'll be keeping it in the ICO stage. And rest of the amount is 1.25 billion is in the owner's account. Okay, so these are the bifurcations of my cryptocurrency token creation. Like, I want to have bonuses also, I want to have stages also, how many total supply should be created for the token, how much should be in my account, how much should be in the pre-ICO stage. Okay, yes, these all the things are depending upon developers. Okay, whatever the people feel like to do it, what is the requirement of our project. Okay, so it depends upon this. So this has to be differ. What new is there now? This all logic I have told you, it will be written in the same fashion how we write it in other languages also, but the terminology is little bit different. Like address, we have to use it whatever we want to type in the balance of the address and all. Okay, now what I have written it here is function stop ICO. Stop ICO. Creation of the ICO will be stopped by the owner only. Okay. Who is the creator? That person can only stop the creation of ICO. That we have to code it externally. Like function stop ICO, external function, only owner. Only owner can stop the creation. Okay. Release ICO. Only owner only can release the ICO again. If it has stopped due to some fraud reasons or something like that, he can stop it. If he want to resume it, he only can resume it. No other person can resume it. Okay. So that is the thing where we can just code it. And then there is a total supply. Let me just run this code, and then on the basis of what we are going to see the output, we'll just see it. Okay. And now, okay, after writing a code inside this Solidity, okay, remix platform, we have to go to this third option, the files option. After the search option, after this is a compiler, Solidity compiler, where you have to just select the version, click on the compile class.sol. It, if it is green tick, it is compiled successfully. If it is not, then you will have some errors in the red down below, where below this compilation details, and then you have to just sort it out. Okay, what is, mainly people just do this compilation error where the version does not matches. So that you need to just be careful about it, how we have to just see it. And then we have to go to the fourth option, which is a deploy and run transaction. Okay, now in this deploy and run transaction, we have an environment. Okay, and now in this environment, the JavaScript VM London and Berlin, they are helping us to deploy this contract within this remix Solidity only, where we are not using any other platform for deploying the contract. Okay, so these two allow us to deploy it internally. Injected web3 is nothing but the metamask which we are using it. Okay, like this, we you must have seen it in the earlier in the earlier lecture. Like MetaMask is a wallet, okay, where you can just create accounts, keep your ethers here, and we have a private key access to it. So I have many accounts, like account 1 2 3. You can create n number of accounts. You will be having only one private key. When you will create a account, you'll just get to know what is private key and all. Okay, so I have just selected a account 1. Now if I want to do this deployment on the test net, which I have selected a Robston test network. So there are many test networks available in the market. Like these are the Ethereum test networks. Robston is there, Coven is there, Ninkibai is there, Gurley is there. So what we have to just select is any of the test network we can select. We should have test faucets for it, okay, available in our account. So like this, if I have 4.9767 ethers. Okay, so these are not the real amount. Okay, these are the test faucets, yeah, the pseudo faucets. Yeah, the pseudo amount I am just having it to test whatever I have written it in the remix, or just deploy any contract on the testnet of the etherscan.io. Okay, so let's try with the injected web3. Okay, what I'll do, I'll just do injected web3, and my MetaMask opens it. Now, when they opens it, I need to select which account I want to do the transactions for. So I'm just having more ethers in account one. Let's go to the account one. I'll click on next. I click on connect, that they are asking the permission that Remix platform and the MetaMask should be connected or not. We just confirmed it. When it is confirmed, we get to see that environment injected web3 is selected, and Robston 3 network. 3 is the network ID. Ethernet mainnet is the ID 1. Okay, like this it varies. So Robston is having the 3 ID. Now you will see that in the next part, my account address is there, 0xEA5. Let's verify it. 0xEA5. Okay, so perfectly my account is connected. It is showing me connected also in the MetaMask. My balance is also getting reflected into the remix, and whenever I'm going to deploy this class.sol file, okay, I will be getting all of the notifications in the MetaMask to do any transaction. Okay, now in our blockchain, whenever we are going to just deploy any contract, that again comes into the transaction part, and then we have to give some transaction fees to it. Okay, and then only it proceeds further. Fine. So what we will do, we'll just deploy this contract, and let's see what do we get. So if I say deploy, my MetaMask pops up, and it just ensures me that you are going to give estimated gas fee is of this much amount. Total, you will be spending this much amount of ether to do, or to do this deployment on testnet, that is Robston test network. If I confirm, my this class.sol will be deployed on the Robston test network. You can just see that it is showing me a link view on Etherscan. If I click on this, automatically it will redirect me to the Robston test network through which I have tried to deploy it, and it is still showing me in a pending state. Okay. Now, when it turns to a successful state, then my contract deployment is done. I have created a contract. Whenever we deploy a contract, we get an address to it. Now, this is my contract address, which you are seeing it here is 0x8361 and so and so. So, whenever I will be having transactions within my contract and someone else address, this contract address is to be referred. That means if you all want to buy my class token, you need to have this address, this contract address. Okay, so whenever a token is created, obviously if we want to monetize it, or we want to get money out of it, and we want to just publish it and make money, and just what we can say, marketize it, we are going to create a website for it, and on the website, or on the face of that particular application or of the token, like how we see in the Bitcoin, address is there. Okay, in that particular section my contract address will come. So whatever ethers you drop in, that will be on this contract address, owner's address. Okay, through this only it will be having a transaction. Okay, whatever in and out. So this is important. So the deployment is important to get this contract address, and this needs to be used throughout the what we can say, the whole stages. Okay, now my contract is created. Let's go to this. If you scroll down a bit here, you can see deployed contracts, and there is a arrow sign. If you click on that arrow sign, you will see all of the functions which I have created. Now, some functions are orange in color, some functions are blue in color. The functions which are orange in color are as the private functions. Okay, that are the private functions are the private keywords which are only visible to a owner. Okay, it is to be accessed by owner only. No public people can just see it or can access it. The blue functions, okay, whatever the blue features which we have it here, can be called by public also. Okay, there are the public functions, like public can see the symbol of my token. Yeah, we can see it, CLS. Public can see at which stage I am, that is zero, that is not started stage of the ICO. Public can see the total supply of my particular token, CLS token. Yeah, that is 2.5 billion. Yes. Then public can see the owner. Owner is, right now we have just deployed or created the contract. Now when we'll click on this class coin is nothing but my contract, okay, which I have written, function class coin. When I'll deploy this, then only my address will convert into a owner's address. Okay, that means all of these class token and CLS will be my own token. Okay, so if I click on this class coin, again a MetaMask pop-up comes up. Okay, my this transaction will be held. There are some gas fee which I'll be giving it for carrying out this transaction. I'll click on confirm. Again, it will show me on view on Etherscan. It will be pending. And after that, I'll just see if I click on owner, this 0x00 should change it to my address. That is 0xEA5. Okay. So when it is done, we'll just check it. It's still in a pending state. Yeah, right now we have got the confirmation of the block in this console window. Green tick is there, and we have successfully deployed our class coin. Okay, and if I click on the owner now, my that address 0x000 is changed to 0xEA56029. Yeah, whatever my address is there. So I will be the owner of this class coin. Okay, the class CLS token. So this is visible to the people. Now what is the name of this is class, that is public function, because everyone can see that. Okay, people can see how many decimals are there inside my tokens. People can see what are the amount of ethers received. We haven't done any transaction, so we have not got any ethers right now. And how is the bonus token to be distributed, what is the bonus, what it should be when it is in the pre ICO stage or when it is in the ICO stage. Okay, all kind of things. What is the total supply right now? Yeah, this is then price token. What is the face value of my token, which is 20,000? If you give me one ether, I'll be giving you 20,000 ethers. Sorry, 20,000 class tokens. Yeah, so this is the thing which are accessible by public. They can just view it. Now, what are the operations a owner can do is they can approve, they can drain. Drain means whatever the left out tokens are there, apart from the bonus and the ICO stage, whatever the tokens are left out, they'll just burn off. Okay, by calling this function. Yeah, that is a extra feature which we are having it on our token. End ICO, if we want to end our ICO generation. Fixed specification, if we want to release ICO. If we want to start ICO, if we want to start pre-ICO, these all authentications or this is authorized to a owner only. Yeah. So this all features need to be accessed by owner, and then only the process or what we can say passing on to the tokens to the people can be done. So let's see if I want to have a start pre-ICO stage. If I click on this start pre-ICO, I'll just get another confirmation. So whatever the private functions are there, okay, I'll be getting one of the notifications. If it is a transaction related, I'll need to just verify with the MetaMask. I am going to give some transaction estimated gas fee, and then that particular transaction goes ahead, and we can just pass on our tokens to some other account. Okay, now this has done. Let's see. Now as I have started this pre-ICO stage. Okay, I'll just see what is the pre-start date. Now, pre-start date is a this big number. Now, this big number is a timestamp. Okay. Now, epoch's timestamp converted. If there is an epoch converter, okay, if you just paste this amount, okay, what is this number on that epoch's time converter, and just click on it, should be converted into a human time converter, or it should give me a human date. It will be today's date, that is 25/6/2022. Okay, so this thing you have to just check it. Solidity do not give us in the uh, time which we see it in our daily life. Okay, it just convert into this, and if we want to just check it, you can just convert it in an epoch converter. Okay, that is a timestamp, Unix time. This is called as a Unix time. Okay, so this is the pre-start date. Now, as we have coded inside this, the pre-start date should be up till 30 days. Okay, till 30 days, my pre-ICO stage is there. Within that, if people buys, I'll be giving them the bonus token depending upon the calculation which I have decided it in our code. So this is the thing how we can just proceed further of writing any cryptocurrency token. Now this was a little deep deep dive into how you can create a token basis or not helping of any other library. Okay, now let me come to a simple thing which people use it nowadays, Open Zeppelin. Okay, with that will be a little easier for you to just code it. Now, what the Open Zeppelin does, they help us to create a contract, okay, or a token, very in a easy fashion. Okay, now whatever that I have used it here. Okay, let me just show you. Mm, the total supply, the token balance of, function transfer from, which I have written it. Okay, like after transfer from, that means from my account it should be deducted and then it should be deposited to some other account, or whatever the account is. It should be all of the calculations which I have, which the computer needs to do, I have mentioned it in the function transfer from. Again, in the approve function, what it should do, I have mentioned it. Function allowance, I have manually written it. Function transfer from and transfer is different. Transfer means automatically it will take owner's address as the from address. Transfer from function will allow you to enter some else's from address and then to address, and then you can perform the action. So that is this manually I have written. Then there comes transfer token function, and there comes transfer by function. What logic it need to be written. Transfer ownership, if I have to transfer my ownership from my account to my friend's account, now I will not be the owner of this class token, I want to transfer it, then I have written a function for that, how it should work accordingly. And then there is a drain function, like if the left out class tokens are there, I will be burning it off. I will not be taking advantage of those extra tokens, but whatever it is regularized in the market, it will be in the market, and no other tokens will be generated hereafter when there is a commitment to the customer or commitment to the users. So we'll be calling or using this drain function. So what I have written is, in this all 297 line of coding, I have made my own functions. Okay, with this all we were updated and Open Zeppelin came up. Open Zeppelin just gives us an inbuilt functions. Okay, now if I have to create an ERC20, ERC20 is a cryptocurrency standard where we can just create a cryptocurrency on top of it. So these are ERC20, 721, 1155. I'll just tell you in detail tomorrow if you need it, when we'll be creating some NFT projects or like. But today, as we are creating a cryptocurrency ERC20 token, so it will be referring to the ERC20. Okay, so my token will be, let's say my uh, I'll just erase it and write as at Nikita token. I'll just make it as NKT token, and I'll just make it as mintable because I am not writing it that how much total supply is should be there, correct? And these are the extra features which you wanted. If you want to burn it, pause it, permit it, if you want to have a votes on it, flash minting, snapshots, extra features given by Open Zeppelin. Okay, access control levers, it should be ownable, or if I want to define some roles to it. Okay, so I have click on ownable. Now what I'll do, I have only this much line of code. I'll go to open remix. Okay, easy way of creating a token. Now with this, I'm able to create a token within 13 line of coding. Why? Because imports of this open zeppelin erc20.sol and access ownable.sol is having all the functions which I have written it manually in my earlier code. Okay, so if I click on this compile contract, it is compiled successfully. And let's go to deploy. And if I click on this, it is JavaScript VM. Okay, it is going to use the internal EVM machine to deploy this contract, not the injected, because I haven't selected here the injected environment. So MetaMask will not pop up in this case. I'll click on deploy. Okay, the contract may be abstract, it may have an, okay, so if there are some gas limitations, or wherever we can see that this particular contract is not what we can say directed for a function, okay, then it just gives us this type of message that your contract is abstract and all. Okay, but this is a simple way of how you can create a token, how you can have your own functions like all of these which we have created it here, reflected in the same way in the open zeppelin. But this is a manual way of writing. Open Zeppelin is a way of using those inbuilt functions or importing those libraries and making the token, and minting those token easily for n number of what we can say, like how I have restricted in my coding style is 2.5 billion only should be created. So there you can just mint it as per your wish. Okay, like how many n number of tokens you can just create it, that is your way of coding or your style of coding. Okay, so that is the thing how we can create your own cryptocurrency by manually and by open zeppelin. Not only open zeppelin, there are different kind of libraries also which helps us to do so. There are kind of truffle suit, hard hat is there, where if you don't want to use remix, you can use those truffle suit or hard hat to deploy or compile your contract on your local machine. Okay, so remix is helping us to compile and deploy your contract on online basis, on online platforms. If you want to have your smart contract, if it is in, if the smart contract is in your local machine, if you want to compile those, test it and deploy it on the test nets or either on the main net, you can use truffle suits and hard hat also. Okay, so these are another platforms which help us to do the similar thing like the remix help us to do. Clear with this? Okay, so this was a basic thing like how we can create it and how to deploy all of these things, and yeah, create it in the market. Any questions up till now?
Ma'am, there is a question.
Yeah.
Uh, Ma'am, can you tell about optimized solidity?
Optimize solidity. Okay, so as we have discussed, okay, like how I have told you the basic keywords of access modifiers are there, then enum, yeah, defining the structures for it. So whenever you want to optimize it, a simple way of optimizing the code is using the open zeppelin kind of thing, okay, where you are going to import some of the libraries. Number of lines of code just gets into that, and you are easily what we can say good for it to deploy the contract, like how I have showed it right to you right now, 13 lines of code, okay, where I have written 300, almost 300 lines of code to do the same thing, okay, and it was just covered with the open zeppelin import libraries with 13 lines of code. Okay, so that is one way. If you want to optimize it more, you can use structures, which I have told you that if there are number of applications or number of categorizations in your project. So suppose I have just taken an example of the school project or any of the institute where you will be having schools, students category different, teachers or senior teachers different. So you can just club those what we can say the data types, and whatever you want to call it, you can just call that particular structure, and then you are good for it. So you need to write that code again and again in the contract, okay, or you need not need to call it again and again.
Ma'am, someone asking for the PDF.
Yeah, yeah, sure, sure. I can just share the PDF with you all guys. No issues.
Yeah,
The code,
definitely.
the basic understanding of the code, right? The Open Zeppelin one, it is easy to go. You know it how you can just simply tick on those features you want and open it and remix and deploy it. Yeah, I can just give it to you that PDF also.
Okay. So, guys, anyone having any question, you can feel free to ask. Or tomorrow we are having same time a session on. We will deep dive into Solidity more. So, if you
Yeah,
have any kind of question, feel free to ask right now, or tomorrow you can ask. So there are some feedback that really amazing session.
yeah.
So okay,
Thank you.
so we can end up the session, right, ma'am?
Yeah, yeah, yeah. We can end up the session.
Okay,
I'll just share the PDF with you. You can just share it with everyone. Yeah.
sure, ma'am, sure. So
Sure.
thank you everyone for joining this session, and thank you Nikita ma'am for joining us.
Thank you
And
so much.
tomorrow we will meet again, and we will deep dive into solidity. Thank you
Yes, yes.
everyone for joining.
Thank
Have
you
a
so
nice
much.
day.
Thank
Bye
you.
bye.